Hello! We are starting a new topic today on mechanism design, specifically to auctions. So far in this course, we have been given games to analyze. In mechanism design, we become the ones making these games. We want to design games so that players are incentivized to achieve certain overall goals. For example, in an election, one possible goal is if more people prefer A over B, then A should win. In an auction, which we will talk about soon, one possible goal is that the player who values the item the most should win. Or perhaps we want to maximize the revenue for the seller. In sports tournaments, we might want to structure the rules so that the best team should win, and teams play the best they can. Of course, there could be problems. Players look after themselves. They want to play so that they get the most benefit, and they will find loopholes and advantages for themselves to avoid playing as the game designer intended. There have been examples in some football tournaments where the rules allow situations so that it is more beneficial for players to lose than to win. In one case, this leads to players trying to score their own goal. It is hilarious, but it is not what the tournament director intended. Links to these examples are in the description. The main question then is that, as the game designer, how do we set the rules so that the players who play for themselves will also achieve these global goals? We will look at this from the context of auctions. Now, auction theory is still an active research area. The 2020 Nobel Prize for Economics was won by two economists who designed new auction formats. A link to more information on this is in the description. In an auction, the auctioneer is selling something, and players bid on the item. The auctioneer needs to decide on the rules for two things: who wins what item and who pays what amount. We have seen one auction before, and that is the second price auction. In this auction, the rule for who wins what item is player who bids the most wins. And the rule for who pays what amount is the winner pays the second highest bid, and everybody else pays nothing. Now there are a lot of nice properties of the second price auctions, and we want to generalize that to other auctions as well. One nice property is that a player bidding their valuation is a dominant strategy. This means that they will get maximum utility if they play their valuation. This kind of strategy is called truthful bidding. This property makes the game easy to play. Even without knowing everyone else's valuation, bidding one's own valuation will maximize utility. Now, truthful bidding is not necessarily a dominant strategy for other types of auctions. For example, the first price auction. We will leave the proof of this as an exercise. Another nice property is that if players give truthful bids, then their utility is never negative. So there is incentive to bid their valuation anyway, as it never hurts them. One possible auction that does not have this property is the all-pay auction, where every player pays regardless if they win or lose. We combine these two nice properties into one definition to apply to general auctions. An auction is dominant strategy incentive compatible, or DSIC, if truthful bidding is a dominant strategy and yields non-negative utility. We will be a bit more lenient in the definition of a dominant strategy. Dominant strategy here means weakly dominant, except we don't require a case that decreases utility. Now, having the DSIC property is great in the sense that the players don't have to think much about what to bid They just bid their valuation, and that is the best that they can do, and they never lose money. However, having DSIC is not good enough. There may be some DSIC auctions that have less desirable effect. For example, an auction where we give the item for free to player 1 is DSIC, but this does not seem like a good auction to have. So what we need is an overall goal. Our goal here is that the item should go to the player with the highest valuation. And this is related to the concept of social welfare, which is the sum total of the values received by all players. For a one-item auction, only one player receives the item. If player I wins the auction, then they receive value VI, which is their valuation. The remaining players receive nothing. So the social welfare is VI. To maximize social welfare in this case, we make sure that the player with the highest valuation wins. And this is easy if players bid truthfully. We just give the item to the player with the highest bid, and that will be the player with the highest valuation. So that gives us the following definition. An auction is welfare maximizing if truthful bidding results in maximum social welfare. There's one last good property of the second price auction. The second price auction is very easy to run. We can quickly determine the highest bidder and the second highest bid. So we can combine all the properties we have discussed so far to say the following. An auction is ideal if it is DSIC, it is welfare maximizing, and it can be implemented efficiently. And based on what we have learned so far, we know that the second price auction is ideal. As we will learn later, the second price auction is the only single item auction that is ideal. But of course, we should look for ideal auctions for applications beyond the single item auctions. In the next lecture, we will discuss sponsored search auctions, where there are multiple items with different values for auction.